doing 1.4, defining a power. I've started off with what I think might be review, and that is x to the power of m. Am I right that have you learned about base and exponent and power? Or are those all vocabulary words that you've heard of or learned about before? Is that new for anybody? And again, that's just me trying to figure out where we're starting. Okay, so overall, the whole thing would be called a power. But just the big number is the base, and the tiny little number at the top is the exponent, right? You can think of it this way. The exponent is needy. It needs something to latch onto. You could never just have a tiny little exponent hanging out by itself, right? So we've looked at the rules of exponents and the rules of algebra, where algebra is all about opposites. But we could never get rid of the x here without the exponent being dealt with first, because we can't just leave a little exponent hanging there at the top. Good? Okay, can I get you, Jeffrey, to do me a favor and just close the door, not completely, but just a little bit? So the next thing, and I think this might be review for you, is if we have something like 2 to the power of 4, that is the same thing as saying 2 times 2 times 2 times 2, which is 16. So when you see the exponent of 4, that tells you how many times you're going to multiply that 2 by itself. And then moving on to something where it's a little bit different and we're having to work backwards, we could have something like this, where we have 5 to the power of x equals 125. So it's like we don't have all this stuff in the middle. We don't know what that is. We just have the answer and what it's equal to. And we're sort of thinking backwards and trying to figure out what it might have been. So we could start by saying 5 times 5. And what does that give us? 5 times 5? 25 times 5? It's 125, so what is the x value here then? Yeah, it would be 5 to the power of 3 equals 125. So therefore, that's my little symbol for therefore, we could say that x is equal to 3, and that's what our answer would be. So far it's review? Okay, so then moving along, if we get examples like this, there's subtle differences between, well, look at the negative 5 to the 3, and then look at the next one, negative 2 to the 4 is in brackets. So let's start first with this negative 5 to the 3. If I wrote that in expanded notation, does that mean negative 5 times negative 5 times negative 5? No, so what do I do with that negative? If it's not in a set of brackets, we just leave the negative in front. So I'm going to put the negative there because there's a negative in the answer. And then this is the part that's saying 5 times 5 times 5. So then what's the answer? Yeah, negative 125 is what we would get. So if there's a negative in front, we know that the answer is negative. Good? Next one, negative 2 to the 4. What does this one mean if we're writing it in expanded notation? Yeah.
Negative 2 times negative 2 times negative 2.
Good. Negative 2 times negative 2 times negative 2 times negative 2. And so notice the subtle difference between this one and the last one. Do you see in the last one the negative sign was outside the brackets? This time the negative sign is inside, so we are multiplying that out. So what do we end up getting for our answer? What is negative 2 times negative 2? Positive 4. Positive, so that's that one and that one. What's positive 4 times negative 2? Positive 4 times negative 2 would be negative 8 times negative 2. We end up with a positive 16 for our answer. Yes?
Isn't the rule like if the number being exponentially grown is negative, but the exponent is an odd number, it's going to remain a negative. But if it's an even number, it's going to become a positive.
Excellent. Did everybody hear that and get that? Basically, if we look at this number here, if the exponent is an even number, like 2, 4, 6, 8, any of those, and there's a negative inside, we know by looking at it the answer is going to be positive. So I don't need to actually write negative 2 times negative 2 times negative 2 times that. I can just look at that and decide, okay, my answer is going to be positive. So I can ignore the negative in that case, and I can just put the answer there. Good? On to the next one, negative 2. Oh, actually, let's leave that there so we can compare the subtle differences. This time, it's negative and then 2 to the 4. Is the answer going to be positive or negative? In this next example, negative 2 to the 4 right here. Is the answer going to be positive or negative if there's no bracket there? Yeah. It's going to be a negative answer. So we might as well start with that and get that out of the way, and then we can think, what's 2 to the 4? You're going to have these memorized if you didn't already because you're going to see them repeating over and over again, but after doing the last one, what's 2 to the 4? 16. So our answer this time is negative 16. Good? Questions? On to the next one. Ooh, negative 1 in brackets to the power of 100. Forget the answer. Is it going to be positive or negative? I mean, forget the value or the number, but is the answer going to be positive or negative? That's what we'll start with here. Yep. It's going to be positive. Everyone agree with that? So it's kind of like I can just ignore the negative there. And then what's 1 to the power of anything? It's just 1. So the answer would just be 1. That's going to be our answer there. Good? I'm just using different colors for no reason. They don't serve a purpose today, but that's all right. Okay, so then let's compare with the next one. For this next one, negative 1 to the 99, is the answer going to be positive or negative? Negative 1 to the 99. Is 99 odd or even? Oh, you can tell it's first thing in the morning. Is 99 odd or even? Odd. So then is the negative still going to be in the answer? Yep. So the answer is going to be negative. And what's 1 to the power of anything? Itself. So negative 1 would be the answer in that case. Good? On to the next one. Again, I've purposely put these beside, or I guess above and below one another so we can compare. Is the answer in this case going to be positive or negative? Yeah. It's going to be negative, right? Because there's no brackets there. Even though this is even, the answer is still negative. And then what is the answer? Negative, it's still just 1. 1 to the power of anything is always just equal to 1. And in this next one, is the answer positive or negative? It's negative, and 1 to the power of anything is 1. So you can see the comparison. If there's no brackets, it doesn't matter about the odd or even thing. It's when there's brackets there with the base that makes a difference. So there's a lot of teeny tiny nitpicky little details with this stuff. Again, I don't know if you've done this before. Have you done 3 to the power of negative 2? Have you dealt with negative exponents ever? Alex? You've seen them? Do you know what to do with them? You can leave it a little bit open, Liam. Like, that's perfect. Thank you.
Still want it open, apparently.
Or you can close it. It's all good. Alex, what were you saying? Do you know what to do if it's a negative? Don't worry about it.
Isn't it like
kind of. You deal with the reciprocal. So does everybody know what a reciprocal is? I'm going to use that hand gesture. If you have a number like 3, when you go like that and take the reciprocal, it's like you flip it and turn it into 1 over 3. So you flip the base and take the reciprocal. So the reciprocal of 3 would be 1 over 3.
Anybody have to take?
You can leave it, Liam. Don't worry. Just put it on the table there. Thank you. And then when we do that, this -2 becomes +2. So the answer in this case would be 1 over 9. That's way too thick. Let's fix that. So this is the one that I feel is brand new that you've probably never done before. And so we'll go through it a little bit because I feel like there's a little bit of getting used to with that. When you have a negative exponent, the trick or the key is that we flip the base and take the reciprocal. Do you see if I have a number like the number 3 here? Technically, I could say if I want to turn it into a fraction, it's 3 over 1. We could turn any number into a fraction by putting it over 1. We just normally don't, right? So that's why when we flip it, it turns into 1 over 3. It's that imaginary 1 that's underneath the number that we normally don't write. So we'll get rid of that because it's not really there. Are there questions about that, the 1 over 9 or the flipping and taking the reciprocal? Okay, here's how it could get a little bit tricky, or there's a bit more happening. We only have variables. We have mn to the power of -3. Only one of them is the base. Only one of them has an exponent on it. Which one has an exponent on it? What's the base? N. So we're going to leave the m where it is, and let's deal with, I'm going to put brackets there. If I want to change that -3 to positive, what does the n become? Actually, let me use colors for this one. So for that, what does the n become? If I want it to be positive. Yeah.
1 over n.
1 over n. And then what does the exponent become? 1 over n to the power of 3. Does that make sense so far? And then if we want to deal with that, the best way, well, what's the best way for us to give that answer? If it's m times 1 over n cubed, do you see I could multiply the m and the 1? So we could say m over n cubed. Questions?
If you multiply the m into the fraction, would it go on the bottom as well? Or not?
Good question. No, because the m was always at the top. It didn't have a negative exponent. It was started off at the top, so that doesn't move to the bottom. The m stays at the top. The only way it would is like, let's say I had a -1 or a negative something up there, then it would. But because it just started at the top, it stays at the top like that. Alex?
What if m and n were in brackets?
If they were both in brackets, then yes, they both would be at the bottom. If they were both in brackets to the power of -3, then yes, they're both
But
at the
when they're
bottom.
both in brackets, do you have to write them with separate terms, like 3, like m to the power of 3, n to the power of 3, or you just write both of them together with the...
Either would be fine. Yeah, as long as if you didn't write them both to the power of 3, then you'd have brackets there. Don't worry, we'll practice different ones like that. Do we get this so far? We're okay with this concept? I feel like negative exponents sometimes throw people off. And then, you know, there's a bunch of stuff to keep track of here. Sort of makes your head, this is a good way to wake you up in the morning. -2 to the power of -3. First of all, what's the base in this question? If I were to ask you the base, is it 2 or -2? It's -2. Then, if I want to make this exponent positive, how do I rewrite this? 1 over negative 2 to the positive 3. Everyone good? Positive. That's why we do this, is to turn that negative exponent into a positive.
Oh,
When we flip it and take the reciprocal, that negative 3 up there becomes positive. Good?
is it because if you like multiply the -2 and the negative?
Good thought process, but no, we wouldn't, the negatives in this case aren't really related. Yeah. So this is sort of a rule that we're just going to have to memorize, which isn't satisfying in math. But if you see a negative exponent, know that it ends up being 1 over and getting flipped. So then working our way through it, we have negative 2 to the power of 3. Is the answer going to be positive or negative? It's negative and the exponent is odd. We'd have a negative. And what is 2 to the 3? 2 times 2 is 4 times 2 is... So we could write it like this, 1 over negative 8. Do you see that that's the same thing as saying negative 1 over 8? Or even if I put the negative at the top, they all mean the same thing. But the key is you only want the negative at one spot, in one place. Questions? We're okay with this so far? Good? Ooh, what's anything to the power of 0? Yeah, Mitchell?
1.
Sorry?
1?
Anything to the power of 0 is 1. Even if it's a massive, huge base like that, what is that number if we were to name that number? 52,435, right? To the power of 0, but it's still just equal to 1. And how about to the power of 1? Anything to the power of 1 is just that number itself. So far we're okay? Well, that's your assignment.